Afternoon, everybody. Hey, Demarcus and Gilles, thanks for joining. It is the 16th of June. This is the VMware Cloud on AWS Customer Success Architect Office Hours. Nice short title, as always. A slight change from the norm today. What we're going to be doing is we have my colleague and friend Gilles online, who is one of our specialist engineers, and he's going to talk us through the new feature that's just been released. Called the VMware Managed Transit Gateway, or vTGW, or VMware Transit Connect, or whatever else we want to decide to call it next week. But yeah, it's got a few names, so if you hear it referred to as one of several things, it's probably the same thing we're actually talking about. What I'm not going to do is talk for too long today, because Gilles has quite a lot of stuff to go through. But please feel free, as always, to pop any questions in either the Q&A or the Zoom chat boxes. If you're watching live on Twitch, feel free to give us a shout out there as well. Over to you then, Gilles, if you don't mind taking it away.
Thank you, Will. Last week, actually Friday, the week before, on June 5, release 11 is been popped out, okay, just like a surprise. And this release has a lot of new networking stuff for VMware Cloud. And this is really a major release, although 1.11 would not be like everybody upgrade to 1.11. Now we only upgrade customers to even number, so 10 or 12, and this is 11. But if you really want it, we can do something for you. So let me go through the agenda. First of all, I want to go through a quick introduction to AWS Transit Gateway. This is really basic. I'm going to show what is a transit gateway, how do we work with it, the routing tables, and all the rest of it. And then I go and do a recap on Direct Connect and Direct Connect Gateway. Those are really important stuff. Then we're going to talk about the VMware Managed TGW, or VTC, VMware Transit Connect. And quickly, I will go through the step-by-step build that we have in the lab, or we had, because we are doing a complete rebuild of the lab right now. So I have a step-by-step build of everything that is needed to be able to build, multiple SDDC connections, VPC connections, and I will show some connectivity tests. And then a few slides at the end about migrations. How do we migrate from an existing environment to this new architecture? And a couple of slides on future, what we are working on. It's a pretty packed agenda, so let's go for it. First of all, transit gateway basis, okay? Transit gateway is a region construct that connects multiple VPCs together through VPC attachment. These VPC attachments are really high speed. They are 50 gig connections. And a transit gateway is like, although I show only one here, is a very highly redundant uh, device that sits in the region. It's built on AWS Hyperplane, and this is something that does not really fail. Okay, so we have also capabilities to connect to on-prem data center via VPN connections with 2 tunnels always, and via a direct connect gateway. So it's quite simple. If we look at the routing table on the VPC, you stay local with 10.0, but any other, uh, if you want to go to on-prem like 172.16, then you just send your data to the transit gateway. And the transit gateway will have the intelligence to know where to send the data over VPN, over direct connect, or any other type of information done. On the other end, the transit gateway learns a lot. It learns from connections. So every VPC you attach, we learn the VPC CIDR, okay, and that's a VPC attachment, but also with corporate data center or VPN, then we have BGP sessions that we can learn about data center um, networks. So or VPN or direct connect gateway with virtual interface where we will have BGP information. So it's really highly available and scalable. We can connect thousands of VPC on multiple accounts with Transit Gateway. Very flexible in routing. Every VPC has elastic network interface, and we can have up to 10,000 static routes, multiple routing domains, so you can have 20 route tables in a transit gateway, and we will see how route tables are important when we do specific things. So I'll take an example here of a flat model. What is a flat model? A flat model means I'm going to connect VPCs to my transit gateway and I want all of them to talk to each other. So this is kind of simple. I take like the 10.1 local address, and everything that starts from 10, I say, okay, send it to the transit gateway. And so every VPC I add, I have the same routing table, okay? And then the transit gateway learns about all the VPC attached, and then, the communication is very simple. So every VPC can talk to every other VPC. We have a default routing domain. That's like what we call a flat domain. There is another model that is called isolated model. And here I say I want my VPC to talk to on-prem, but I don't want them to talk to each other. So the easy way to do that is to simply code a 0/0 route that sends the data to the transit gateway. So here in this transit gateway, I have two routing domain. Okay, so the first one gets the data that needs to go out. And here in this, I say any route, send it to my VPN. Okay, so any route I send to my VPN, this is like a default routing domain in this VPC route table. So I have full connectivity. Every VPC can go to on-prem via the VPN. And also I learn my way back. So if I have any data coming from on-prem and needs to go to VPC attachment 2, I know the way to send it. So here I have east-west connectivity, but no connectivity north-south. So this is important. And I really wanted to present these two domains because these two models, because we are using them in the VMware Transit Gateway. Okay? Direct Connect. Direct Connect is something very nice. It's a dedicated network over an AWS backbone. You have various speeds, 1, 10 gig or less if you go via partners. It's consistent performance. Its data charge are reduced, okay, about more than half from if you compare or even you know maybe 20% of what you would pay from an internet connection. It has a physical and a logical connectivity via something that AWS called a direct connect location. So direct connect locations, there are many direct type, maybe 80 or something like that, direct connect locations around the world. And within the direct connect location, you have an AWS device and a customer device. And these two are connected with fiber optic, something called cross connect. And you can have 4 of them and you can do a link aggregation with 4 of them. Okay. Next to that, you have your service provider, usually MPLS networks that go back to your customer router on-prem. We have different type of virtual interface in the Direct Connect stuff. So first one is a private virtual interface. It's used to connect to VPC using private IP. Okay, it can be directly attached to a VGW, so virtual private gateway, and that is supported on VMware Cloud. Or it can be attached via Direct Connect Gateway, and today it's not supported on VMware Cloud. Second is a public VIF. So public VIF used to connect to all AWS public services, S3, DynamoDB, Lambda, all type of services using public addresses. And the third type is a transit VIF. So this is a virtual interface that is used to connect to transit gateways via Direct Connect Gateway. At the end of the day, all virtual interfaces are 802.1q VLANs with BGP peering. So how does this work? How does it connect? A private VIF link between the VPC and the Direct Connect location router. So we have a VPC, we have a VGW, we establish a private VIF with BGP between the customer router and the VPC itself. Okay, so the way it works, VPC is going to advertise its CIDR with BGP, and we will receive any on-prem network also with BGP. And here we need to be a little bit careful. So if I want to go on-prem, I send all my data to my VGW. That's very easy. And I need to be careful because I have a maximum of 100 BGP prefixes. Okay, so this is important. If you go over 100, your BGP session will go down. So 100 coming in, 100 going out. And here I should say, instead of BGP route, I should say prefix, because you can actually do a summarization. The next thing is Direct Connect Gateway. And on Direct Connect Gateway, I'm going to use in the next slide a lot of colors and a lot of lines to be able to understand exactly what is connected to what. Okay, so Direct Connect private VIF. First of all, a Direct Connect gateway is completely independent of region. Okay, you create a Direct Connect gateway, it ends up in AWS cloud, not in a specific region, not in a specific VPC. It's just a global construct. Okay, now we can connect up to 10 VPCs to that Direct Connect gateway with something called VGW association. So we have VGW association up to 10 per Direct Connect gateway. And then we connect a private VIF. So one private VIF can talk to 10 VPCs in that scenario. The PGP session terminates now on the Direct Connect gateway. Remember, before it was terminating on the VGW. Now it terminates on the Direct Connect gateway. And then you can do that with multiple regions and multiple accounts. So there is no limit in terms of how the VGW association is connected. This traffic is allowed. Okay, so from VPCs to on-prem, this traffic is not allowed. You cannot talk to between two VPCs via the Direct Connect gateway. All right. The next one is Transit VIF. Now we are adding, we have our Direct Connect gateway. We are adding transit gateways. So transit gateway is a region construct. So now the transit gateways are within regions. They are connected to VPCs. And then we can have up to 3 associations per Direct Connect gateway. So this is also important. Um, and then you connect the transit VIF to it. So once you do that, there are some limits. Now we have up to 20 BGP prefix only, not 100, only 20. And so we have three association that gives me 60 prefixes going to on-prem and 100 coming back. Okay, go figure. Anyway, you need to be careful of all these things. TGW can connect to thousands of VPC behind the transit gateway. So think about summarization. It's very important. This is allowed and this is not allowed. And by the way, if you have a direct connect dedicated connection, you have only one transit VIF. We will see. I have a slide on that later. And the public VIF ends on AWS cloud also, not any VPC or not any region. It just ends in AWS cloud and then connect every public service to this public VIF. And AWS has thousands of public AWS services. So think about filtering. There are a lot of ways to do filtering on that. And one interesting fact is that VPN, if you use it with a VGW or a transit gateway, also use public IPs. So when you create a VPN connection, AWS is giving you two tunnels. These two tunnels, the end of these tunnels are using public IPs. And since they are using public IPs, they will be advertised on a public VIF. Something interesting because now you can actually have your VPN traffic go over your direct connect. This is really cool. Connection types, three connection types, very important slide. Okay, the first one is what we called or AWS called a dedicated connection. Dedicated connection is 1 or 10 gig and has a lot of virtual interface, 50 public or private virtual interface and one transit virtual interface. So it's total of 51 VIF. Okay. Um, the other two are from partners and only from partners. So the second one is called the hosted connection, and the third one is called the hosted VIF. Please be careful with all these names. Dedicated connection, hosted connection, hosted VIF. You know, let's see what is a hosted connection. The hosted connection is also some kind of dedicated connection, but now it goes from 50 meg to 10 gig in multiple ways: 100, 200, 500, 1 gig, 2 gig, 5 gig, 10 gig. This is provided by the partners, but it has only one VIF, only one. And you can choose that this VIF is a public or a private VIF or a transit VIF if you are over 1 gig. Very important. And the third one is a hosted VIF. So again, coming from partners, from 50 to 10 gig, can be oversubscribed. I should say will be oversubscribed, okay, because this is some kind of shared connection that your partners is giving you. And a hosted VIF has only one VIF. It's a public or private, but no transit VIF. So remember, if you want to go with transit gateways, forget about hosted VIF. You can go with hosted connection or dedicated connection. So let's have a look a little bit on design. So I can have multiple private VIF going to multiple VGW. I can add a public VIF, no problem. I This traffic is allowed. I can even do routing between the BGP session on the customer router in the DX location, or if it's not possible, maybe back to on-prem customer router. That's okay. If we go with private VIF and Direct Connect Gateway, we can mix. So I can have a private VIF to a VPC and a Direct Connect Gateway with another private VIF and VGW association. That's fine. So this is allowed This is not allowed. I cannot mix transit gateway and VGW associations on a direct connect gateway. So if I have a transit VIF that goes with a transit gateway association, I cannot add a VGW association to it. Okay, this is also important. So, or you have all VGW association or all TGW associations. And by the way, if you want to learn more about it, these are active links on AWS that you can actually have a look. Again, transit VIF and private VIF, you can mix if they are separated. Okay, so you have your private VIF going to your VPC VGW and the transit VIF associated with your TGW. That's allowed. In terms of scalability, so if I have a private VIF, I have one BGP session. If it goes to a VGW, I have only one VPC. So one BGP to one VPC. That's not very scalable. So if I add a direct connect gateway, one private VIF can go to 10 VPCs, a little bit better. But if I use a transit VIF, then I go to a direct connect gateway and I go to a transit gateway, and there I can have thousands of VPC behind. And remember, I can attach 3 transit gateway to a direct connect gateway. So that's really scalable. Money, how much that cost? There are no charge for direct connect gateway. That's good news. The charges are those of direct connect, according to the speed you are going to use and who is giving you the service. So if you have a dedicated connection from AWS, it's 1 or 10 gig, and those are the prices. If you have a partner hosted connection, it goes from 50 to 10 gig, and those are the prices. The prices are per hour, per port, the way that you connect, okay? I have 1 gig connection, it's like a port in the AWS router, then I pay 30 cent per hour on that port. This is important. Now, once I have this set up and I have my port allocated and I pay per hour, I also pay per data transfer. So if I send traffic out on the direct connect, I pay 2 cents per gigabyte egress charge. Coming in is free. This is US and Europe. If you go to Asia or Latin America, it's much more expensive. So check the regions. And this is also the link of the direct connect prices into Amazon. Transit gateway also costs money. Okay, transit gateway is not cheap. It costs 5 cents per attachment per hour. So if I have 1,000 VPC attached, it's going to be 1,000 times 5 cents per attachment per hour. Okay, and in Europe it's 6 cents, apart from Dublin. And on top of that, you are also paying 2 cents per gig that is processed by the transit gateway. So here we don't talk about egress or ingress charges. We talk about data that goes through the transit gateway. And who pays? The sending account is charged this 2 cents per gig. Okay. So it can come in, it can go out, you will pay 2 cents per gig that is processed by the transit gateway. So within the VMware Transit Gateway, also known as VMware Transit Connect, we did some work with Amazon to be able to integrate the transit gateway into the VMware cloud on AWS. And it's a VMware own transit gateway connecting multiple SDDCs and VPCs together, and that belongs to the org shadow account. You know that when you create a VMware org, there is a shadow account. Every VPC belongs to the shadow account. The transit gateway from VMware will also belong to that shadow account. SDDC must be in the same region. And that's normal because the transit gateway is a region construct. Okay. SDDCs must have non-overlapping management network. Why? Because the management network is actually the VPC CIDR from an AWS point of view. So you cannot connect VPCs with the same CIDR. So here we must have non-overlapping management network. SDDC should have non-overlapping NSX segments. But that's no big deal. If you have overlapping NSX segments, we will reject them. Okay, they will be disconnected. So the VTC architecture, if we take SDDC standard architecture, we have an edge, we have two tier one management gateway and compute gateway with a management part and a compute part. Okay. Now, we always have an attached VPC that is connected through an ENI to the tier 0 edge. We have also internet gateway to go out to internet, and we have vGW if we need to connect a direct connect. Okay, so that's one SDDC. If we take a second one, the same one, then what we do is we create an SDDC group. Okay, so we can create an SDDC group, and then we we create our intention to connect these two guys together. And once we create an SDDC group, then we create a transit gateway at the same time, and we attach the two SDDC now with VPC attachment. And that goes to the tier 0 router also. And this VPC attachment is very high speed, 50 gig. Okay. Next to that, I can have a customer VPC. And a customer VPC can also attach to our transit gateway. And if I want to go on-prem, I use my transit gateway association to a direct connect gateway that goes back to on-prem. Today, it's the only capability we have. We are thinking about other things, but today, that's the only way is to go via a direct connect gateway and a transit VIF. So facts about managed transit gateway. One org can have multiple SDDC in multiple regions. There are no limits on that. But when you create an SDDC group, then all SDDC are in the same region. And the SDDC group is a region construct. It's because we are using a transit gateway. One SDDC belongs to only one group. Although within AWS, we could connect a VPC to multiple transit gateway. Here, it's a one-to-one relation. The vTGW will be shared under Resource Access Manager. And this is on the customer AWS console. So the customer should go and accept the share. Once he accepts the share, it can create VPC attachment on the AWS console. And we need to go back to the VMC portal and accept these VPC attachments. The route table we use, we have two route tables, one for SDDC to SDDC to VPC, and that's the open, okay? It's the flat model I described at the very beginning. So everybody talks to everybody. And we have a second route table. This is one for VPC to VPC, and this is closed. This is an isolated mode, and this is only any-to-any deny. So a VPC can only talk to an SDDC. They cannot talk to each other. If you want to do filtering, you can do filtering with SDDC compute gateway firewall rules that you need to apply to the direct connect interface. Okay, today only direct connect for on-prem connectivity. So let's build, and I'm going to fly over the slides. This is what we had in the lab because it's been destroyed right now. I have two SDDC with two different management network, 10.20 and 10.10. I have four segments. So on SDDC 1, 10 and 11, on SDDC 2, 20 and 21. I have four virtual machines, so two on the .10 network and two on the .20 network, okay? I have two VPCs that I'm going to attach to them, 221 and 222, and I have an EC2 in each of them. So this is the lab setup, okay? I have here two SDDCs, two VPCs with customer account and VMware accounts. I have a virtual transit gateway that has VPC attachment to my SDDCs and VPC attachment to my VPCs as well, okay? So first things, we need to create an SDDC group and attach the SDDCs themselves. So for that, we have a new tab, and this new tab appears when you go to Action and then create an SDDC group. So you create a group, you give it a name and some description. You select the SDDCs you want to attach, so they need to be in the same region and they need to have different management CIDR. That's okay. If you want to attach only one SDDC, it's also possible. And there is something I need to update here. Although here the versions of the SDDC were 1.10 v2 and 1.10, now we are enforcing 1.11 since we released it about 2 weeks ago, 10 days ago. So 1.11 minimum. Once this is done, you go and apply the layer 3 connectivity, and then we warn you about charges because at this time we will create a transit gateway and the attachment that goes with it. So after a few minutes, you get an SDDC group with two members, okay? And the members are my two SDDC, 1 and 2, and status of layer 3 connectivity is connected. So now I have a new icon in my overview, and the new icon says SDDC group. I can click on it. When I click on it, I get this new tab, which is called SDDC interconnectivity, and I'm not sure we're going to keep this name, but that's a new tab. And here I can see the routes that are advertised by SDDC1. So what do I advertise? I advertise my management network, I advertise my default segment and my two segment, 10 and 11. This is a mistake. This is segment 11, not 20. Okay. If I look from SDDC2 point of view, I have a problem because SDDC2 also has the 192.168.1 network. So both of them, oops, sorry, both of them are going to be rejected. So I have here failed and failed here. So I'm not going to learn this route from SDDC1, and I'm not going to advertise this route on SDDC2. Okay. So this is what I see from a connectivity point of view. That does not mean that I have connectivity. Okay, I need to add firewall rules. So I need to go to my gateway, my compute gateway, and add some firewall rules that will allow SDDC1 to talk to SDDC2 and back, and apply those to the direct connect interface. Once it's done, I have connectivity. So a VM in SDDC1 can talk to VMs in SDDC2, okay? And if I have the proper firewall rules here and here, then everything is fine. Once this is, oh, I did a couple of tests. Interesting, because our host interfaces is 25 gig physically. Okay, so I did a quick test with two VMs on two SDDCs with jumbo frames, and I used iPerf, and I got about 12 gig send and 12 gig receive, which is about 24 gig at, on one network interface. Not bad. Now I want to connect AWS account, and I want to connect customer VPCs as well. So first I need to go and add on the VPC connectivity tab, I need to add an AWS account. And when I do that, I'm going to share, or VMware is going to share the transit gateway to that account. So I need to go and look in AWS Resource Access Manager in the proper region and look for an invitation. I would see an invitation from VMC group, and I can see that the shadow account is, the one that belongs to VMware or to the org, and then I need to accept it. So I accept it, and I have now a transit gateway available in my console. I am the customer, and this owner account ID is the shared um, with VMware shadow account. Great. So I have a transit gateway. I can now attach my VPCs. So I go and create transit gateway attachment. So I select my transit gateway. That's the one that was shared with me. And I attach my VPC. Here I attach my VPC 221. Okay. And I can do the same with 222. So I have now two attachments that are pending acceptance. Okay. So they are pending acceptance. Why? Because I need to go back to VMware Cloud and accept these connections. Okay, so I need to go there and accept the transit gateway attachments. And after a few minutes, um, the attachments are available and they are also associated. Good. So now I can see in the roots I'm learning from the vTGW, I can see my two VPC, 221 and 222 over here. Perfect. So one thing I need to say is that when you attach a VPC to a transit gateway, you learn about the VPC CIDR, the global one, not any specific network or subnets or anything that is inside. You learn the global CIDR from the VPC. And if the VPC has multiple CIDR, which is also possible, you will learn all of them. But this is normal behavior from AWS. If you need filtering, you need to apply firewall rules on the edge, okay? So here, first of all, I go to my default route table. Let's say this is VPC 221, and I want to add routes to my SDDC, okay? So here I could do something very global, like 192.168.0.0/16, only one route, and then everything goes. But here I can go specific to specific networks and allow some and deny some, and they all go via the transit gateway. Once I do that, I need to go back to my compute gateway, allow who talks to who. Again, I can do some filtering here, and then I have my connectivity. So now my VM can talk to an EC2 on VPC 221 or on the other one, VPC 222. I have the full connectivity. VPC to VPC is not allowed, okay? This is a decision from the business unit. We can argue with it, but for now, on the first release, this is not allowed. So this is yeah, some pings if you want to have a look. And that's it. From a migration point of view, today we don't have VPN attachment to the transit gateway. It's only direct connect gateway to the transit VIF. Okay, this is important. Another thing is you can mix AWS Transit Gateway and VMware Managed Transit Gateway because a VPC can be attached to up to 5 transit gateway. So if I have multiple VPCs here, I can attach them to an AWS Transit Gateway. And then I have a direct connect gateway that can have 3 associations. So here I'm building 2 associations, and I have my transit VIF that can go back to on-prem. So this is a valid design. Today, there is no way to connect a transit gateway to another transit gateway in the same region. Okay, this is not supported. No way to connect a VMware Managed Transit Gateway to an AWS Transit Gateway, although we are working with Amazon about it, but today that's the only way to do. There is no transitive routing via any type of SDDC. So if I have today an SDDC with a direct connect, this is standard connectivity, and I'm adding a second SDDC, and I do SDDC grouping, and I add customer VPC, I cannot, well, I can talk directly from SDDC1 to on-prem, but I cannot talk from SDDC2 via SDDC1 to on-prem, or from the VPC, neither. So this is really important, and we need some way to migrate from the standard direct connect connections that we have with many customers today if they want to use a VMware Managed Transit Gateway. So how do we migrate? We have 2 options. Option 1 is we have a dedicated connection. That's great. We have 50 VIF and 1 transit VIF. So we can leave the direct connect private VIF as it is. We are creating our SDDC group. We are building the VMware Managed Transit Gateway. We create the direct connect gateway, and we connect the transit VIF. Perfect. So now I have connectivity between SDDC2 and SDDC1 via direct connect gateway back to on-prem, no problem. If I don't have a dedicated connection, then I have a hosted connection, and I have only 1 VIF. So what I need to do is I need to disconnect the direct connect private VIF. This one has to disappear. And then I can create my group and my transit gateway and my direct connect gateway. And now I can use a transit VIF instead of the private VIF I had, because I have only 1 VIF on a hosted connection. So I need to choose private, public, or transit. And if I connect to a transit gateway, I need a transit VIF. Done. In terms of future, what we are developing is actually this type of connectivity. So the first one will be between region, okay? So today it's supported by AWS. You can peer transit gateway in different regions. Today we are working with AWS. It's a roadmap item to peer an AWS transit gateway to a virtual transit gateway. It will come later. And the second one, even more interesting, is to peer transit gateway in the same region. So today, AWS does not support it, and VMware Managed Transit Gateway, of course not. And it's also a roadmap item that we are looking and working with AWS on. And that's all I have for you.
Gilles, thank you ever so much for doing that presentation. That was really really good.
Okay, timing is good. Okay.
Yeah, it was really good. Thanks, mate. I was just looking to see. We had a question from Joel about the slides. I believe these are your slides currently, right? But you are working on a blog or some publicly available.
Yeah, they are
or?
public because we released M11. We released 10 days ago, so I can share the slide.
Brilliant. Okay, Joel will be happy. Thank you for that. I will get them over to you, Joel. I'll get a copy off Gilles and send them out.
Yeah, I'll send it. I'll send it. I'll send everything to you, Will.
Awesome. Thanks, mate. Does anybody online have any other questions for Gilles or for myself right now? You're all on mute, but you can unmute yourselves. That's not a problem. Quiet gang today, I think, Gilles. I think you've lucked out, mate.
I think everybody understood. I mean, this is so clear. Come on.
Yeah, totally. To be fair, as you were going through, I was writing questions down to ask you, and then you've pretty much covered them all anyway. So
I try to. It's a complex subject.
Yeah, I guess so. The futures bit, the peering bit is, I guess, going to be sort of one of the most requested features. Yeah.
So peering is very important. A lot of people are asking, I don't have a direct connect stuff. Okay, I want VPN. Yeah, okay, man. I mean, we can't do everything for a first release.
Yeah.
So we have to cut features for the first release, and this is what we have today. And depending on the demand and the good mood of everybody, we will add more features later.
Yeah, absolutely. We find out what we can, what gets requested, what works, what doesn't work, and then we release. Joel, you've raised your hand. Are you going to ask about the session or an actual VTC question? Yeah, absolutely.
Yeah, we can hear you.
Hi, I just was a little bit late to the presentation. I had a conflicting meeting, but anyway, is this released? Is this future?
Yes. Yeah, it is released. It's released on version 1.11 that has been officially released on June 5, so it's only 10 days ago. Now, not everybody will move to release 11. This is something new that we have introduced. Now, the major updates of release are going to be on even number. So we will have like a major release on 1.10 and another major release on 1.12, and this is about 6 months now. Okay, so 1.11 is available, and if you want to have this VMware Transit Connect and SDC group stuff, then you can ask a preview. So it is preview, it is available, but you will need to upgrade your SDC to version 11, okay? And to be able to do that, then we need some specific flags on the organization so we can upgrade. Because today, even if the release 11 is released, if you go and deploy a new SDDC, it will be on release 10, okay? It will be on release 10 version 4 from yesterday, and but not on release 11. So this is not something automatic you're gonna have. If you are interested, please contact me or contact Will, and we will forward this request to the US and have a preview. So this is in preview for the next, I would say, 2.5 months until release 12 is coming, like end of August timeframe. Okay.
Okay, that's great.
So let me know, or let Will know, and then we can forward the request and have some specific design session. We need design session with every customer. All right.
I see, Joel. I see you said you were working with Jason Crocker, who's based out in North Carolina. So yeah, if you want to reach out to him as well, and he can get in touch direct also.
Okay.
Cool.
Great, and I'm rather new to this whole VPC thing, so I'm not even sure how it applies. I mean, right now we're have a VPN connection back to our transit gateway for the rest of our AWS deployment. So I'm not sure how that
Yeah,
affects all that.
yeah. So you have an AWS Transit Gateway with VPN connections. Okay. Yeah, yeah. It's a little bit problematic today. Today, the only on-prem connectivity we support is via a direct connect gateway. So you need a direct connect. But
And is
we need
that
to
new?
take it.
Because
We need to take
that,
it offline,
yeah,
and
sure.
it's very important also for me to bring customer feedback to the US. For prioritization of new feature. If we got today, we don't have VPN, but we could have VPN. Okay, now it's development, testing, and it takes time. So if we have a lot of customers coming back to us and say we absolutely need VPN connections to on-prem, we don't have a direct connect transit leaf, and all the rest of it, then this is important feedback for me to be able to push that as well. Okay,
Yep, sounds good. Thanks.
excellent.
Cool. Thank you for the questions there, Joel. And thanks again, Gilles, for stepping in at the last minute and running us through that. It's very useful. And I know that there's going to be quite a few comments and people viewing this on YouTube later on. So if you do have any questions later on, please just post them to YouTube and we will try and answer them. And I think if there's nothing else from anybody, we'll give you 8 whole minutes of your day back. Thank you, everybody, for joining. I'm not going to do the usual round robin that I'd normally do today, so DeMarcus and Zach, you're off the hook today. Well done. Normally we do a bit of a round robin, find out what people are working on, so you're free and clear this week. So thank you everybody for joining, and I will catch you again on the next session.
Cheers.
Thank you.
Thanks, Jan. Thanks, Ed.